Going to solve another lead code problem. The problem title is Serialize and Deserialize a binary tree. So it's a very popular problem. So in this problem, we have to serialize the value of the binary tree, and the output of the serialization will be a string, and we need to use that string and have to create the same tree that we had earlier. So it's a pretty simple problem. I think the solution is easy for that. Let's jump into the solution. So for the serialization, we can use BFS or DFS, but for we will focus only the DFS and pre-order approach only. So if we want to serialize this tree, we have to traverse the tree in the pre-order way, and the output of this binary tree will be like 1 2 3, then null null, then 4, then null null, then 5, then null null. Let's see it in animation. So first 1, then 2, then 3, then null null, then 4, then null null, then 5, then null null. So this is the serialized string. So we have to design. Now we know the logic. Now we just need to write the code for that. Let's start. To save this serialized string, we will first create a global variable here, serialized string. Then we will write the code we needed for pre-order search. First we'll get the value of the root, then we'll add this root value in the global serialized string value, and we will also add a comma to separate the node values, so later on we can identify uh, uh, the node values using this comma. So this is a simple code for pre-order traverse, and for the exit condition we need this. So when the root when we approach on the leaf node, we will return from there, and for the leaf node, actually leaf node left and right, we will add a null string. So at the end of this traversals, there will be something like this for this tree. So it will be 1 2 null null, then 3, then 4 null null, then again it will go to 5, then null null. So this is the serialized string. Now we have to use this string and construct the tree again using our deserialize function. So the code for the deserialization function are pretty much like the serialization function. First, we need to split the string and convert it to an array. Later on, we'll pass a list on a inner deserialize function. In this function, we will do like this actually. So first we will remove the first element of this serialized string and add it and create a root node using this value, and on the root dot left we will recursively call this inner ds function. This will actually populate the inner left tree, and for the right tree of the root element, we are calling the inner ds recursively again. So this will populate the right tree. Okay, and for the termination condition, we need to like this, because we have for the leaf node, when we got a leaf node, we'll just return the null node. Actually, that's pretty it. And actually, um, this is not like readable. The code is not readable. User usually don't understand how the tree, how we are creating the tree using those string values. So I have created a graph uh, to simulate this code. Let's go there. What happens? So this is our uh, code to construct the tree from the serialized string. So what happens? Let's say first it will create the root node. Okay, it will remove this one, and this line will be executed, and this node will be created. Okay, then it will create the node 2, and then what will happen? Then it will create for the node 2. When it will go to the left, it will find that it's a null, so it will return a null, and it will assign the null to the left of 2. Then again for node 2, it will check the right. For the right, it will find null, then it will assign the null to node 2. Then again, uh, the left of the node 2 will be assigned in the left of the root node, and the process will go that way. Then it will create the 3 node, then it will create the 4 node, then it will assign the null on the left of the 4, then right of the 4, then it will 4 node will be assigned to the left of the 3, then go one after another. Actually, it will follow the same recursive calls and will construct the tree this way. So finally this tree will be constructed using this code. Now for time complexity, as we are traversing the node only once for serialize or deserializing, so the time complexity will be big O n. And also for the space complexity, as we are using the recursive stack for each node only once, so the space complexity will be big O n. Yeah, that's it. Thank you so much.